If you try to do much iOS pen testing or hacking or any sort of research or anything that requires looking at the binaries of iOS applications, then you've probably come across the issue where you download an application from the App Store and you're able to get the app on your phone, but you still need to get the IPA file to do some sort of static analysis or some sort of reverse engineering or something like that on the actual binary itself. Well, in this video, I'm going to show you how you can extract the IPA file from an app that's installed on your device. And then I'm also going to show you a little bit about how you can take that binary and then you can use it with some tools to do some static analysis or reverse engineering or things like that. So let's get started. There are a bunch of different tools out there that you can use to extract the binary from an iOS application. One pretty common one is this Frida iOS dump tool that you can get off GitHub. But for this video, I'm going to be using this tool called bagbak. Both bagbak and Frida iOS dump use Frida as kind of like the back end of what's doing the work to actually extract the binary. But in my experience, bagbak's just a little bit easier to use. There's not as many like configurations and things you have to do. So that's what I'm going to be using in this video. But because this does use Frida, we are going to need to install Frida on our iPhone in order to do this. And we are going to need a jailbroken iPhone in order to install Frida. I made another video a while back where I showed how to actually jailbreak an iPhone, and I'll put a link up here in the corner if you want to check that out. In that video, I also went over how to install Frida, but I'll go over a quick rundown right here. Basically, all you need to do is once you have your iPhone jailbroken and you have Cilio installed, and then you're going to add the source build.frida.re. And then we're going to add source. And once that source is added, then you can search in the packages for Frida and you should be able to find it and then install it here. And to install Frida on your machine, you're just going to run pip install frida-tools. I've made several videos at this point showing how to install Frida, how to use Frida for different things. So if you want to get more information about that for either Android or iOS things you want to do with Frida, feel free to search on my channel and you should be able to find a few things to check out. But now to install bagbak, there's actually an npm package for it. So you can just run npm install-g and then bagbak. Once we have Frida installed and we also have installed bagbak, now I'm going to connect my iPhone with USB and I'm going to get started actually extracting the IPA file. The app that I'm going to use for this example is Threads. If you don't know what Threads is, it's a fairly new-ish social media app from Instagram. I want to say it came out like maybe 8 months ago or something like that. But I think it's kind of fun and interesting to check out newer apps that have come out and that are kind of becoming popular, just to see if there's anything interesting in the source code or anything that we can find from static analysis or reversing. So this seemed like a pretty good use case for extracting an IPA and then doing some static analysis on it. The first thing I'm going to do is run this little Frida smoke test with Frida-PS-U lowercase ia. And this is just going to make sure that we're actually able to communicate with our device with Frida. And it's also going to show us all the apps installed on the device and show us the package name for those apps as well. So if we look down in this list that we get, we see that Threads is right there. Now that we know that Frida is working and we can communicate with our device, I'm just going to run bagbak with the name of the app, which in this case is Threads. And when we ran that, it started downloading all the files and it's decrypting them and pulling them all down to our machine. And then once that finishes, we have this IPA file, which now we can do any sort of static analysis or reverse engineering or anything we want to with it. So now that we have our IPA file, there are a few different things that we might want to do with it during our static analysis or reverse engineering process. And one of the things that we might want to do is run it through a disassembler in order to take a look at the assembly code. This can be useful for looking for like hard-coded API keys or passwords, stuff like that. And if you actually get good at reading assembly code, you can use that as a way to see more insight into how some workflows work. And you might be able to use that information as part of your dynamic analysis as well. Now, there are a few different tools out there you can use to disassemble an IPA file. I've talked about Ghidra before on this channel when I was working with reverse engineering Android applications. And you can use Ghidra for iOS applications as well. But just because I haven't talked about it before on this channel, I thought in this video I would show you a little example of how to get started using Hopper. If you've never used Hopper before, you can download it from hopperapp.com, and I believe it works on both macOS and Linux, but I don't think it works on Windows. There is a license you can purchase for $100 if you want that, but they also have a free trial that you can get where you can basically use the tool for free for 30 minutes at a time. And once that 30 minutes runs up, you will have to close the app. And if you want to use it again, you just restart it and start a new session. So if this is something you use on a daily basis, that's a little bit frustrating and might not be worth it. And maybe you want to actually go ahead and buy the $100 license or just use a free tool like Ghidra if you prefer that. But if you're just using it every now and then, or if you're just doing some minimal reverse engineering to search for like hard-coded keys and things, then that 30-minute time period is probably going to be enough for you in most cases. But for this video, I'm just going to show you how to get started with the free version. So all you're going to do is just download it from this downloads page, either for Mac or Linux, whichever one you're working with. And then once you have it installed, when you open it, it's going to ask you for your license file. But if you don't have a license because you just got the free version, then just click try the demo. And now we actually need to import our binary. But instead of just importing that entire .ipa file, we're actually going to unzip that IPA file. And when we do that, we're going to get a payload directory. And then inside that payload directory, we're going to have this file that's going to be the same name as what the actual application was when it was installed on the phone. And we can right click that and click show page contents. But if we scroll down a little bit, we should find this file, which is going to be, again, the same name as what the app was when it was installed on our device. And this should be listed as a Unix executable file, and this is the file that we're going to actually use with our Hopper Disassembler. So we're just going to drag and drop it into Hopper, and I'm just going to leave all of these settings as default, and I'm going to click OK. And once that process starts, it'll probably take several minutes to actually complete all the analysis. And if you look down in the bottom section, there's actually a little log right there that says analysis pass 1 of 11. So I would recommend waiting for all 11 passes to actually finish, and once that says 11 of 11 is complete, then you can actually start searching through that code for whatever you're looking for. And if the app that you're working with is a larger app, this can actually take a pretty significant amount of time, like several minutes, and that can really cut into that 30-minute demo time. So again, depending on your use case, you might be better off paying that $100 for the license or using a free tool like Ghidra. Honestly, I don't consider myself enough of an expert or experienced enough in reverse engineering to actually be able to recommend either Hopper or Ghidra or any other tool for that matter. But if you are using Ghidra, you might want to remember that you are using that same process. You want to get that executable file by unzipping the IPA file and everything like we did for this. You don't want to just like take the IPA file and run that through Ghidra. You actually want to unzip it and extract that executable file, which is what we did before we pulled that into Hopper. Okay, so now after several minutes have passed, it says down at the bottom that analysis pass 11 and 11 was done. It says last pass done. So now all of that code is disassembled, and now we can start looking through it and see if we can find anything interesting. Like I said, I'm not an expert on reverse engineering, but what I would normally do at this point is I would start searching for some keywords of something I might want to take a look at more. And over on the left-hand panel, you'll see that there's a search function, and it has labels, procedures, and strings. I would normally start with strings and just see if there's some keyword I want to look for. For example, Threads just recently started rolling out support for the Fediverse, so maybe I want to take a look at the keyword Fediverse and see if there's anything interesting that comes up. So if I search for Fediverse, I might start looking through it and seeing if there's anything interesting there. And I can just click on one of these keywords and see what comes up. And maybe I can right click on that and look at references to that. And then that might take me to something else that could be interesting. And there's also this option up in the top that will let you look at pseudocode mode. And this can actually break it down into a little bit easier to understand code instead of just that assembly code. So now if we click that, this code is a little bit more readable, so you might be able to figure out what's going on a little bit easier here than just looking through the assembly code. And you can also search for procedures instead of strings. So over on the left, if I click on the procedure instead of strings, and that will just bring up a list of a whole bunch of procedures, and I can click on one of those, and that might give me some more procedures that are related to the Fediverse or whatever keyword I want to look for. And inside these procedures, you might see these subroutines, and if you want to take a look at those, you can just click on that, and that can send you down a rabbit hole going deeper and deeper into the code to try to figure out what's going on. But this is sort of the basic idea of how you would use Hopper to kind of break down that source code of the application and look through and try to sort of understand what's happening in the code, as well as trying to find like hard-coded content that might be a security risk. So just to recap, we first extracted an IPA file from an application installed on an iPhone using the tool bagbak. And then after we had that IPA file, then we extracted the executable from it and ran that through Hopper so we could disassemble it and take a look at the source code. And I'll say it one more time, I'm not an expert in reverse engineering. In fact, iOS reversing is probably the area where I have the most still I need to learn. But I hope I was able to give you at least a little bit of an intro and get you started on learning how to reverse engineer iOS apps. Maybe this can start you on your journey to becoming an expert reverse engineer, and then maybe you can teach me something.